In this video, I will quickly review what is expected value, variance, and standard deviation for a discrete random variable, and specifically what are the formulas for binomial random variables. Let us start. Let's start with fixing a random variable. Let x be a discrete random variable. For which we have these values. With values, we know that discrete random variable only has finite values. Let's just say it gets x1 up to xn, and f is its PDF, probability density function. Now we want to define what is expected value of x. So expected value of x, which we denote by e of x, or simply just mu, is a number is given by, it's a number given by this formula. Let me just write mu, or e of x. It is a number. What you do is this: you multiply every value to the probability of x being equal to that value. x2 times probability of random variable being equal to x2, and continue this thing up to xn, and then add them. Well, in other words, we can write this thing. I know that probability of x being equal to x1, this we know it is value of PDF at x1, this is PDF at x2, and PDF at xn. And now we know that if I multiply x1 to PDF at x1, then add it to x2 multiplied to the PDF at x2, and continue up to xn multiplied to the PDF at xn. This is the value, this is the number. We call it expected value or mean for that random variable. It's not just that, we have other things also. Variance. So variance of x, which we denoted by v of x, is given by, it is again a number. How do we compute this number? This time it's a little bit different and complicated. What we do is that, we have the probability of x equal to x1, but this time instead of multiplying by x1, we multiply it by x1 minus mu squared times probability of x1 plus x2 minus mu squared times probability of x being equal to x2, and then you continue up to xn minus mu to the power 2 probability of x equals to xn. You multiply these numbers by their probability and then you add them. Another way of writing that is that x1 minus mu squared times PDF at x1 plus x2 minus mu squared times f of x2, and then goes up to xn minus mu squared f of x. Well, these are the definitions for expected value or mean of a random variable and the variance. Well, there's a third one. I should not forget that one. Well, what about the standard deviation? Well, that's again another number of x we denoted by um, sigma of x, but it is basically um, something that we want to you see there are squares here. Yes, we want to kind of get rid of that squares, so we defined sigma. This is what we call it. It's a Greek letter. Sigma of x is given by square root of variance of x, and we take positive root. Standard deviation and variance are going to be always positive numbers. Let me just write it as a remark. um, Standard deviation standard deviation and a variance of a discrete random variable is always positive numbers. Non-negative numbers are better way of putting that, but that's enough. Well, out of all the um, random variables, there are two important random variables. Let me just write binomial random variable. So for binomial random variables, we have, well, you don't need to do all those computations you see up there. First of all, you remember that the notation for binomial random variable. Remember, binomial random variable basically is counting number of successes in a Bernoulli trial with n trials and the rate of success p for each one. So the expected value of such a thing, such random variable, you don't need to go do all those computations. People have done this and it's equal to np. How about the variance? Variance of b and p is n p1 minus p. And well, obviously then the standard deviation of such a thing, such random variable or binomial random variable is going to be square root of np1 minus p. So these are three formulas that, if you know, will be helpful in general, and you can compute them without going through those hassle of all those steps.